It arrived not as a roar, but as a whisper, a faint glimmer against the dark tapestry of the sky, barely distinguishable from the static of countless distant stars. The astronomers who first noticed it were not seeking visitors from another realm. Their eyes, mediated by lenses and sensors, combed the heavens in their eternal cataloguing, tracing the endless drift of comets, asteroids, and debris that dance obediently around our Sunday. Yet this light did not belong. Its path was skewed, its presence reluctant, as though the universe itself had dropped a piece of its puzzle into our neighborhood without warning. They named it 3I Atlas, the third recognized interstellar object to brush against the dominion of our star, a designation clinical, impersonal, the way science tames the inexplicable with acronyms and numbers. Yet behind that sterile name lay something that disturbed even the most rational of minds, because this was no ordinary comet, no mundane relic of frozen water and dust. It came from the gulf between stars, an exile of unimaginable age, carrying within its silence the story of systems far older, far stranger than our own. The European Space Agency released images to the world, blurred, distant, yet captivating a streak of light against the velvet of space. Humanity, as always, leaned closer to its screens, peering across time and distance, hoping for revelation. But revelation seldom comes without disquiet. Something in those images was wrong, a subtle fracture between expectation and reality, between the comfortable patterns of celestial mechanics and the chaos of what was revealed. For the universe is not obliged to conform to our definitions of order. 3I Atlas, this shard from another sun, carried with it a question that refused to dissolve. Was it merely a wanderer of ice, broken and wandering? Or was it something more deliberate, something crafted, something that had crossed the abyss not by accident, but by design? The hook is set not in spectacle, but in silence, a silence heavy with mystery, trembling with the possibility that the universe is not as indifferent as we once believed. And so the story begins. A comet, not like others, a mirror held up to our ignorance, reflecting the depth of what we do not yet understand. The moment of discovery was almost unremarkable at first. In the quiet halls of observatories, discoveries rarely begin with a thunderclap. They begin with numbers, faint streaks recorded on digital sensors, coordinates inscribed into the endless maps of the heavens. So it was with 3I Atlas, the Pan-STARRS Observatory in Hawaii, forever sweeping its gaze across the skies, first flagged the anomaly. Later, the Atlas survey, built for the practical task of scanning for objects that might collide with Earth, added its voice, and thus the faint light was given a name. At first, astronomers assumed it was what it seemed: another comet, another frozen traveler bound to our sun's leash. These icy wanderers, relics of the solar system's birth, arrive with some regularity, trailing gas and dust as they are pulled into the warmth of the inner planets. They are not strange, they are not terrifying, they are familiar. Yet, as data poured in, the calculations told a different story. The orbit was not elliptical, not parabolic, it was hyperbolic. This trajectory was the first whisper of its alien nature. Hyperbolic paths mean escape. They mean the object is not bound to the sun's gravity, not returning in cycles like Halley's Comet, but fleeing. Fleeing from us, or rather, simply passing through. 3I Atlas was not born of our system. It had come from elsewhere, from a distance so vast that words lose their scale. Perhaps another star. Perhaps from a region between stars where frozen relics drift for eons unlit, forgotten until chance flings them toward another beacon of light. There was precedent. The first was one Oumuamua in 2017, a shard whose strange shape and acceleration left debates unresolved to this day. The second, 2I Borisov, revealed itself as a more ordinary comet, a true child of another system but familiar in its chemistry. 3I Atlas was the third, and in this triad, its strangeness began to shine. When astronomers realized what they had, the tone changed. To glimpse such an object is to hold in your instruments a piece of another world, a fragment of alien history, bearing the dust of stars that lived and died long before ours. It is as if the universe, in its silence, delivered to our doorstep a relic, a message, though one written in a language we do not yet know how to read. What were scientists trying to study when it appeared? They were looking outward, always outward, mapping dangers, cataloguing curiosities. Yet discovery often belongs to chance. The faint streak of 3I Atlas could have been missed, lost in the churn of data, but it was not. It was caught, and with it, humanity was drawn into another confrontation with the unknown. The world would soon see the photos, faint, spectral, and seemingly harmless. Yet the unease began to grow, for in those ghostly images, nothing quite aligned with what textbooks promised. A simple comet should not look this way, and thus the discovery phase ended as it always does, in astonishment, in suspicion, and in the quiet certainty that what we know is less than what remains hidden. The story of 3I Atlas cannot be told without the shadows of those that came before it. When Oumuamua swept into our system in October 2017, it tore open a wound in the comfortable assumptions of astronomy. It was the first time humanity had confirmed with certainty that something from another star had drifted into our celestial neighborhood. What shook the scientific world was not merely its interstellar identity, but its behavior. Oumuamua, elongated like a shard or a blade, seemed to accelerate without the visible tail of gas and dust that explains a comet's propulsion. Its rotation, its light signature, even its silence in radio frequencies, all seemed to whisper of something unnatural. Some called it a rock, some called it a fragment of an alien craft. No explanation satisfied. Then came Borisov in 2019. Unlike Oumuamua, it played the role of a proper comet. Its composition revealed frozen volatiles sublimating into a familiar halo of dust and gas. It was alien, yes, but comprehensible, almost comforting in its similarity to our own comets. In Borisov, astronomers glimpsed reassurance that perhaps most wanderers are ordinary, that Oumuamua was a cosmic outlier, a strange accident. But nature has little interest in reassuring us. 3I Atlas arrived as the third note in this haunting symphony, and it immediately confounded expectations. To place it in context is to recognize the pattern: rare visitors from beyond the sun's domain, each carrying the strangeness of their birthplaces. With Oumuamua, suspicion; with Borisov, relief; with Atlas, unease returned. For these are not simply rocks or ice fragments. They are messages not written intentionally, but inscribed by the violence of stellar birth, the collapse of nebulae, the collisions of planets that may never have borne life. Every interstellar visitor carries with it the chemistry of its native star, the memory of the cosmic nursery from which it was expelled. Oumuamua carried riddles in its trajectory. Borisov carried exotic ices. And Atlas, strangely luminous, strangely shaped, carried contradictions. The legacy of interstellar wanderers is not just a catalogue of objects. It is a slow awakening. Once, humanity believed the sky was fixed, the stars unmoving. Then we learned they drift, they orbit, they die. Once, we believed the planets of other stars were rare. Now we know they are countless. Once, we imagined ourselves untouched by visitors from elsewhere, and now, in the span of a few decades, 3 have arrived. The odds are staggering, and yet the cosmos is vast enough that improbability is inevitable. Still, the pattern unsettles. If 3 have come so quickly, how many more remain unseen? And what do their peculiarities whisper about the nature of the galaxy we inhabit? In 3I Atlas, the legacy of Oumuamua and Borisov echoes loudly. Each discovery forces us deeper into the unknown, dragging behind it the philosophical weight of what it means to live in a universe that throws its secrets into our path without warning. These are not isolated events. They are a chorus, and the song they sing is unfinished, unresolved, and filled with dissonance. The first photographs were almost too simple to stir unease. Against the blackness of the void, 3I Atlas appeared as a pale smear of light, faint and stretched, just one more ghostly comet among thousands recorded in the archives. The European Space Agency released them with little fanfare, accompanied by the usual technical notes and press statements. Yet within the blurred streaks, a silence pressed. For astronomers who studied the frames closely, something refused to align. Telescopes had long captured visitors of ice and dust with clarity enough to reveal the symmetry of their tails, the gentle glow of sublimating volatiles. But in the case of Atlas, the brightness did not spread in the familiar arc. Its form was less a gentle fan and more a fractured smear, as though its light were leaking unevenly, pulsing with a rhythm invisible to the naked eye. The world saw little more than an interstellar novelty. News outlets spoke of another comet from beyond the solar system, linking it casually to Oumuamua and Borisov, weaving the narrative of a galaxy rich in wanderers. But within the observatories, discussions grew hushed. Why did the streak seem to shift subtly between exposures? Why did the coma lack the coherence expected from sublimating ices? Why did the object refuse to be what the textbooks assured it should be? Astronomers knew that discovery is not merely about what appears in the image, it is about what the image fails to explain. And these early photos, for all their blandness to the public eye, became the first crack in the wall of certainty. Consider the history of astronomy. Photographs have always held within them revolution. When Edwin Hubble captured the faint smudge of the Andromeda Nebula and revealed it as a galaxy beyond our own, the scale of the universe expanded overnight. When the Hubble Space Telescope focused on a dark patch of sky and revealed thousands of galaxies where emptiness had been expected, humanity's sense of insignificance deepened immeasurably. Images are not simply pictures, they are instruments of paradigm shift. And so it was again, though quieter. The images of 3I Atlas were not spectacular, not breathtaking. They were instead unsettling. Unsettling because the more scientists stared, the more questions they raised. Had something fractured within it? Was it already breaking apart, a dying wanderer? Or was its structure so strange that the light itself refused to behave as expected? The telescope that caught it was not at fault. ESA's instruments had been honed by decades of astrophysical pursuit. The faint smear belonged not to error, but to truth, a truth that science could not yet articulate. In these early moments, before models were built and theories unfurled, the first seeds of doubt were sown. Doubt not only in what Atlas was, but in whether the universe could still shock us with mysteries that seemed, at once, both microscopic in their subtlety and cosmic in their implications. From the moment its presence was confirmed, astronomers turned to mathematics, the ancient art of prediction, the one tool that allows humankind to claim, however briefly, mastery over the heavens. Every comet's story is told in its path. The orbit is a sentence written by gravity, describing where the body came from, where it will go, and how long it will linger under the sun's dominion. Yet with 3I Atlas, the script would not hold. Initial calculations traced a hyperbolic arc, the telltale curve of an object unbound to the sun, destined not for return, But for escape, this was expected. It marked the comet as interstellar, as one of the rarest visitors imaginable, but as the data refined, discrepancies emerged. The trajectory shifted with each new measurement, slipping away from the models like water from cupped hands. Predictions made one week failed to align the next. In astronomy, trajectories are sacred. Planetary orbits can be predicted centuries in advance with exquisite precision. Even the chaos of comets, whipped by sublimating ice, can usually be modeled with tolerable accuracy. But Atlas defied this discipline. Its course bent in ways that subtle jets of vapor could not fully explain. A faint but persistent nudge seemed to push it sideways, as if an invisible hand were guiding it, refusing to let it obey only the pull of gravity. The scientific community hesitated. Was it radiation pressure, as sunlight pressed upon a surface far thinner than expected? Was it a fragmenting body, ejecting mass in asymmetrical bursts? Or was it something far stranger, a physics not accounted for, a structure not recognized? The question of trajectory became the heart of the unease. For if an object's path cannot be known, then its essence cannot be known. To map is to understand. To fail is to confess ignorance. Atlas forced this confession. Its orbit was not the clean curve of a visitor swept into the sun's embrace. It was erratic, reluctant, almost willful. This was not the first time such doubt had surfaced. Oumuamua, too, had slipped free of prediction, its mysterious acceleration sparking debates that still fracture the scientific world. But with Atlas, the pattern deepened. Another interstellar wanderer, another refusal to submit to the equations that had always sufficed. It was as if the universe were whispering through these emissaries, "Your laws are incomplete." The consequence was profound. If the trajectory could not be trusted, then every other property, its mass, its spin, its future position, was cast into uncertainty. Telescopes strained to keep it in sight, lest it vanish into the void before we could grasp its secret. Each shift in its orbital solution was another reminder. This was not a comet like the others. Its path was a riddle. Its refusal to be pinned down a defiance written across the blackboard of the cosmos. The question lingered. If it does not move as comets should, then what truly is it? Brightness is supposed to be simple. A comet approaches the warmth of the sun. Its frozen volatiles sublimate into gas, jets of vapor stream into the void, and the surrounding coma shines brighter as light scatters from dust. The closer it comes, the more luminous it should grow, following predictable patterns traced in countless cometary curves before it. Astronomers can look at the glow and estimate its size, its activity, even its destiny. But with 3i Atlas, the light betrayed them. Its luminosity did not climb steadily as it neared the Sunday. Instead, it flickered, brightening and dimming with a rhythm that defied cometary logic. At times, it surged beyond expectation, as though something had ignited within it, some sudden engine flaring unseen. Then, without warning, it dulled, refusing the grandeur promised by proximity. This irregular heartbeat unsettled even those accustomed to the chaos of cometary life. Some suggested fragmentation, perhaps. The body was cracking, shedding chunks into space, each burst of light a sigh of broken ice. Others suspected outgassing jets, oriented in strange directions, capable of altering both brightness and trajectory in tandem. Yet neither explanation held comfortably. The fluctuations were too sharp, too oddly timed, almost patterned. They whispered of intent, or at least of a structure not wholly random. For astronomers, brightness is the first measure of truth. If an object shines as expected, it behaves as expected. When it does not, reality itself seems to waver. And in this wavering, memories of Oumuamua returned its light curve too shallow, too inconsistent, suggesting not a natural comet, but a shard stretched thin, tumbling like a blade. Was Atlas beginning to follow that same path into suspicion? The public saw images of a faint smear. The headlines spoke of another visitor from beyond. But in observatories, beneath the quiet hum of cooling systems and tracking motors, eyes lingered on graphs that made no sense. The comet's glow did not tell the story it should have told. Its brightness, instead of revealing, concealed. It became a veil, a mask that seemed almost deliberate. Why would an interstellar fragment, ancient and cold, hide its truth in flickers of inconsistent light? Was it the death throes of a body too fragile to endure the sun's pull? Or was it something stranger, a surface engineered to scatter light in ways nature never intended? The questions pressed, each more unsettling than the last. For when brightness betrays, it is not only the object that is questioned, it is the assumptions of the science itself, the comfort that nature plays by rules. Atlas, in its flickering glow, whispered otherwise. It suggested that light, the oldest companion of human observation, could be made to deceive. And behind that deception, a deeper mystery loomed, patient and silent in the dark. The debate over shape was inevitable. Every comet carries a story in its geometry, its body sculpted by collisions, by fractures, by the long erosion of frozen centuries in the cold between stars. With powerful enough instruments, astronomers can infer this form through the way light reflects and dims as the body rotates a signature, a fingerprint of shape hidden in the flicker of brightness. When these methods were applied to 3I Atlas, the answers did not resolve. They fractured. Some models suggested elongation, as though the comet were a shard, stretched and narrow, tumbling like a blade through the void. Others implied something broader, a body fractured into multiple pieces bound by tenuous cohesion, their rotations bleeding into one another. Still, others whispered of a surface shrouded in dust so thick that no true form could be discerned, its identity smothered beneath a haze. The telescope's eye, sharpened by decades of refinement, seemed suddenly blunt. Why should a simple comet resist being measured? Oumuamua had played this trick before. Its light curve revealed an object so elongated 10 times longer than wide that no natural comet had ever matched it. Atlas, though not so extreme, began to echo the same refusal. Every model left some feature unexplained, some inconsistency unresolved. Its body seemed to defy the binary categories of comet and asteroid, natural and anomalous. Among astronomers, frustration simmered. A shape should reveal itself cleanly, given sufficient observation. But Atlas shifted, as though it wore many masks. Was it fractured, breaking apart with each pass nearer to the sun, so that its form was never stable enough to measure? Or was it something else, hollow, thin, an object designed not by geology but by craft? Theories spread like ripples, a natural fragment torn from a distant collision, a cluster of icy bodies gravitationally bound. Or, whispered in quiet corners, an interstellar probe, a sail of some kind, designed to reflect light in ways that confound. The echoes of Oumuamua's debate returned with weight. Had the universe delivered not one anomalous shard, but 2, 3, perhaps more, each bearing the same cryptic geometry? The shape debate was not simply academic. Geometry determines destiny. A fractured body crumbles, an elongated shard spins erratically. A hollow shell responds differently to radiation pressure. Without knowing its shape, astronomers could not model its future, could not know how long it would survive, could not even predict whether it might shatter before leaving our system. And so the mystery deepened. Atlas did not yield itself to the lens. Its shape, instead of clarifying, multiplied interpretations. A mirror fractured 1,000 ways, none of them complete. In the uncertainty of its form, a deeper truth trembled. that this object might not belong to the categories we had built for it. That perhaps, in its silhouette, lay a hint of something we were not yet ready to recognize. When light is split, when its spectrum is laid bare, it becomes a confession. Every comet carries the story of its birth encoded in the elements it releases as it warms: the hiss of water vapor, the traces of carbon monoxide, the shimmer of cyanide or methane. These molecules reveal the conditions of its natal star system, the chemistry of its cradle. To study a comet's spectrum is to peer into a window of time billions of years old, a forensic reading of a world we will never see. And with 3i Atlas, the confession was uneasy. The first analyses suggested water, as expected. Water is the foundation of most comets, the ice that glitters as sunlight frees it from slumber. But alongside it appeared other compounds in ratios that strained expectation. Carbon monoxide in abundance, hydrogen cyanide in strange proportions, traces of more exotic volatiles that hinted at environments colder than the ones known in our outer solar system. This was chemistry from elsewhere, from a star whose nursery sang in different keys. That in itself was not cause for alarm. After all, interstellar visitors should be different. They are born under alien suns, sculpted in alien cradles. What disturbed scientists was not simply that the spectrum was unfamiliar, it was that it was inconsistent. Repeated measurements contradicted one another. Some telescopes reported stronger signals of certain gases one night, only for them to fade inexplicably the next. The comet seemed to change its chemical story as though shifting its mask, refusing to be pinned down. Theories proliferated. Perhaps the surface was fractured, exposing new ices as it rotated. Perhaps jets of gas were localized, only visible when facing Earth. But beneath these explanations lingered the deeper unease. The patterns looked deliberate. The on-off nature of certain emissions echoed, not chaos, but rhythm, a chemical choreography no comet should know. This brought to mind the debates around Oumuamua, when its spectrum yielded almost nothing, when its silence seemed too perfect. Some whispered of artificiality. With Atlas, the whispers grew louder. Was it possible that its surface was engineered, coated, layered, or hollowed in ways that disguised its chemistry? Or was this simply the arrogance of interpretation, seeing patterns where nature had written none? The chemistry of comets is the chemistry of possibility. From these icy bodies, life's ingredients are thought to have rained upon the early Earth. In the strange spectrum of Atlas, then, was not only the question of identity, but the question of destiny. Did it carry the seeds of some other biology, some alien heritage? Or did it carry only confusion, a reminder that even our most trusted tools, the splitting of light, the passing of elements, can falter when the universe decides to speak in riddles? The data piled, yet the truth slipped further away. In the shifting chemistry of Atlas, humanity glimpsed not answers but the vastness of what remained beyond comprehension. The comet was not simply a visitor, it was a contradiction made manifest, a body whose very molecules refused to tell a consistent story. It was not only the light and chemistry that stirred unease, it was the silence between the numbers. In astronomy, data is currency. Every photon caught, every spectrum mapped, every trajectory refined, these are the lines with which scientists sketch the face of the cosmos. But with 3i Atlas, some of those lines were blurred, smudged, or missing altogether. When the European Space Agency released its first round of observations, attentive readers noticed something unusual: gaps. Some exposures were absent from the public dataset. Some light curves cut off mid-sequence, with no explanation in the technical notes. It was not the first time such omissions had occurred. Space agencies often withhold data for calibration or remove corrupted files. Yet in this case, the omissions were numerous, clustered around moments when the object had behaved most strangely. What had the instruments seen? What was being corrected? or concealed. Inside the community, whispers grew. Astronomers, bound by the etiquette of professional caution, avoided public speculation, but in private exchanges, unease simmered. Were the gaps an accident of data handling, or a sign that what Atlas revealed was too ambiguous or too troubling to release in full? The notion of silent voices crept in, that the instruments had spoken, but their words had been redacted. This sense of secrecy was amplified by the comet's timing. With each pass near perihelion, when activity surged and the object became most luminous, the gaps widened. Observers on Earth-based telescopes reported bursts of brightness that seemed sharper than ESA's official charts. Discrepancies accumulated, small but persistent, like static in a recording. It is dangerous, in science, to lean too heavily on absence. Missing data does not always mean hidden truth, yet here, absence became presence. The silence of the missing frames echoed louder than the published ones. In those spaces, imagination bloomed. Some saw evidence of fragmentation, pieces breaking away, too irregular to model. Others whispered of pulses, light emitted not by chance but by design, cropped from release to avoid public frenzy. History has seen this pattern before. When Galileo's moons first challenged the Earth's place in the cosmos, some drawings were omitted in fear of controversy. When pulsars were first recorded, their perfectly regular beats were jokingly labeled LGM, little green men, before a natural explanation prevailed. Science has always lived at the edge of silence and disclosure. And so, with 3I Atlas, the missing data became part of the mystery, not a conspiracy perhaps, but a reminder that what we see is always filtered by machines, by institutions, by human caution. The comet's secret may not lie in what was released, but in what was withheld. The silences between the numbers became voices of their own, speaking of riddles the universe had chosen to reveal only partially, daring us to imagine the rest. Radiation is the quiet sculptor of the cosmos. Every photon, every particle of sunlight carries momentum. When it strikes a surface, however small, it exerts pressure, a whisper of force that, over time, can bend the path of dust, sails, and comets. For ordinary comets, this effect is subtle, drowned beneath the roar of gravity and the thrust of sublimating gases. But in the case of 3I Atlas, the whisper was too loud. Astronomers modeling its orbit noticed a persistent deviation. Gravity alone could not account for its motion. Jets of vapor, the usual culprits, did not fit the pattern. Instead, the equations resolved only if radiation pressure was exaggerated, as though the comet were far lighter, thinner, more fragile than its faint luminosity suggested. It was as if sunlight itself were pushing it more strongly than physics allowed. This was not unprecedented. Oumuamua had danced to the same strange tune. Its acceleration away from the sun had been too strong for sublimation, too consistent to be ignored. Some scientists proposed a startling idea, that Oumuamua might be a solar sail, a wafer, thin sheet propelled by starlight, whether natural or engineered. The idea was controversial, even ridiculed, but it clung stubbornly to the debate. And now, with Atlas, the echo returned. Was 3I Atlas hollow, a fragile shard whose mass was too small for its surface area? Was it cloaked in dust so tenuous that sunlight gripped it more tightly than usual? Or was it, again, something stranger, a sail drifting across the void, the relic of technology lost or abandoned? The term non-gravitational acceleration appeared in papers and conferences, a technical phrase that concealed the astonishment behind it. For if sunlight could move this object so strongly, its nature was unlike the ice and rock relics familiar to us. It suggested fragility, structure, perhaps even intent. The whisper of pressure is easily overlooked. It is not dramatic, not explosive, but its implications ripple outward. If Atlas was pushed by sunlight more than expected, then its density was far lower than a comet's should be. A porous foam, a fractal aggregate, or something built to ride the wind of stars. In these calculations, unease deepened. The sun itself seemed to be revealing the anomaly, sculpting its path in ways that betrayed its nature. For radiation is honest, it does not lie. If an object drifts in defiance of gravity, it is because something within it is unusual, and Atlas, like Oumuamua before it, was caught in that betrayal. What was once a simple comet now shimmered with the possibility of being something more delicate, more deliberate, more alien to our imagination. A shard that sunlight could command like a sail or a whisper of a design older than our species, drifting unnoticed until it brushed the warmth of our star. The echoes of Oumuamua returned like a haunting refrain. That first interstellar visitor had left a scar on astronomy, a scar shaped like an elongated shard, accelerating without a comet's tail, tumbling in silence across the sun's gravity well. The debates it unleashed never truly ended. Was it a fragment of a shattered world, a sliver of frozen hydrogen sublimating invisibly, or was it, as some dared to propose, an artifact of intelligence, a probe or sail adrift in the dark? No consensus prevailed. The mystery of Oumuamua still lingered, unresolved, hanging over every new discovery. And now, with 3i Atlas, the same shadows began to gather. The comparisons were irresistible. Both were faint, difficult to track, prone to vanishing into the void before instruments could exhaust their secrets. Both displayed non-gravitational accelerations, deviations that could not be explained by simple jets of sublimating ice. Both carried light curves that defied clarity, signals that pointed toward elongated shapes, thin geometries, fragile bodies that might be hollow or structured. Astronomers who had once dismissed the wilder theories found themselves unsettled by the repetition. To dismiss one anomaly is scientific caution. To dismiss two, arriving within a span of years, begins to look like denial. If Oumuamua was alone, it could be excused as an outlier. But Atlas suggested a pattern, a category of object that the universe occasionally casts into our system, each carrying riddles rather than answers. The echoes did not end with mathematics. The cultural memory of Oumuamua weighed heavily as well. Popular imagination had seized upon it as a possible alien craft, and though the scientific community rejected such claims in public, the speculation refused to die. With Atlas, journalists, commentators, and even scientists themselves began to draw parallels openly. The phrase, "another Oumuamua," appeared in headlines, fueling both curiosity and unease. Yet there were differences too, differences that sharpened the mystery. Oumuamua had been silent in chemistry, almost barren of detectable volatiles. Atlas, by contrast, seemed too noisy, flickering chemically in inconsistent ways. One was mute, the other contradictory. One left almost no trail, the other a smeared veil of brightness. And yet both resisted categorization, both evaded the neat boxes of comet and asteroid. In this tension, a question grew heavier. What if these were not singular anomalies, but representatives of a hidden population? A family of interstellar travelers that do not behave like ordinary comets, whose structures are fragile, whose motions are strange, whose presence challenges our assumptions. The echo of Oumuamua was not just a comparison, it was a reminder that when the universe first whispered this riddle, we failed to solve it. And now, with Atlas, it whispered again not as a repetition, but as a chorus. Each anomaly built upon the last, deepening the unresolved melody of interstellar visitation. And in that echo, the haunting possibility emerged. that these objects are not mistakes of nature, but deliberate messengers, cast adrift for reasons we have not yet learned to fathom. Rotation is the hidden heartbeat of celestial bodies. When a comet spins, its changing angles reveal themselves in the flicker of light. Astronomers can measure this flicker, map its rhythm, and deduce the spin rate, the orientation, even the shape of the object itself. Most comets rotate in a manner predictable, steady, their tumbling born of ancient collisions. But when 3I Atlas was observed, its rotation carried with it a strange defiance. At first, the light curve hinted at a familiar pattern, a periodic dimming and brightening that suggested a spinning body. Yet the intervals were inconsistent. Some rotations seemed smooth, others fractured, as though the comet's surface reflected light in pulses rather than waves. Its rhythm was stuttering, not the steady spin of a frozen relic, but the irregular heartbeat of something hollow or structured. This irregularity unsettled astronomers. If Atlas were simply a fragment, its rotation should have obeyed the natural laws of tumbling mechanics, even if chaotic. Instead, the data suggested that its spin was resisting clean categorization. Some models implied it rotated on multiple axes, a complex tumble seen in fragmented asteroids. Others hinted at stability unusual for such a fragile body, as if something within preserved its balance. The word torque entered the discussion. Was radiation pressure imparting not just acceleration, but a stabilizing influence? Could its geometry, thin, sheet-like, perhaps sail-like, cause it to reorient under sunlight in ways no rock or ice could manage? The comparison to Oumuamua deepened, for that object too had spun strangely, its light curve revealing a geometry so elongated that some dared whisper of artificial sails. But with Atlas, the irregularity seemed almost intentional, as though its rotation carried a pattern not of chance, but of purpose. Some light curve analyses suggested repeating intervals, faint echoes of signal within the noise, pulses, not random bursts. And while most scientists resisted the temptation to speculate beyond physics, the whispers grew. What if this was no mere spin, but communication? Even without such bold claims, the implications were extraordinary. If Atlas were hollow, its rotation would behave differently than a solid comet. If its density were vanishingly low, it could respond to sunlight like a sail. And if it were fractured, its shards might rotate in harmony, a broken body that still held coherence, as though bound by more than chance. Rotation is supposed to reveal, to clarify. But here, as in so many other aspects of Atlas, it only deepened the mystery. Its spin did not tell the story of a natural fragment adrift in interstellar darkness. It suggested instead a rhythm half hidden, a dance choreographed by forces we do not yet understand. And in that dance, humanity was forced once more to confront a troubling possibility, that perhaps we were not witnessing the random tumble of nature, but the deliberate pirouette of something more profound. Gravity is the final judge, the invisible law that binds the cosmos. Every rock, every comet, every planet moves beneath its hand. Astronomers trust it because it is immutable, calculable, universal. To measure the motion of a celestial body is to weigh it, to know its mass even across millions of kilometers. And yet with 3I Atlas, gravity seemed to hesitate. The numbers did not agree. The mass implied by its brightness, its acceleration, its rotation, none of them aligned. Ordinarily, a comet's mass can be inferred by the effects of sublimation and sunlight on its orbit. A heavier body is harder to deflect. A lighter one drifts more easily. With Atlas, calculations swung between extremes. At times it seemed too light for its apparent size, as though its bulk were hollow. At other times it seemed too massive to explain its fragile structure. as if it carried some hidden density deep within. Each new dataset contradicted the last, leaving astronomers with models that unraveled as quickly as they were woven. This dissonance was more than academic. It threatened the very framework of celestial mechanics. If its gravity did not match its motion, then either our assumptions about its structure were wrong or something beyond known physics was at play. The idea of a gravity refusal began to circulate, a phrase more poetic than scientific, yet accurate to the unease it provoked. Some theorized that Atlas was porous, a vast sponge of ice and dust with density scarcely greater than air. Such a body would defy cohesion, barely able to hold itself together on its journey across interstellar space. Others speculated about hidden cores, fragments of metals or exotic ices buried beneath a deceptive halo. But none of these reconciled neatly with the trajectory deviations, the radiation pressure anomalies, the inconsistent rotation. And then, the darker speculations emerged. What if the gravitational inconsistencies hinted at structures unknown to nature? Hollow shells, thin sails, frames vast but weightless, the kind of designs an advanced intelligence might craft to drift between stars. To some, this was science fiction. To others, it was a hypothesis born not of imagination, but of necessity, forced upon them by data that refused to comply. Gravity should have the last word. Yet here, the conversation unraveled. The comet's mass and its motion quarreled, refusing reconciliation. Astronomers were left staring at equations that bent beneath the weight of contradiction. And in that refusal, a deeper fear took root, that perhaps gravity was not the only master here, that perhaps something else, unseen, was guiding this fragment across the void, a force, a design, a secret woven into the very core of Atlas, waiting for us to admit that our certainties were never complete. Patterns are the language of the universe. Stars pulse in cycles, planets orbit in rhythms, comets brighten and fade in arcs, as predictable as tides. When astronomers search for meaning in their data, they seek patterns, the faint repetitions that betray order beneath apparent chaos. With 3i Atlas, the search for pattern began in the light curves, and what emerged was neither random nor comfortably natural. The flickering brightness of the comet, first dismissed as noise or fragmentation, revealed intervals that repeated, subtle, buried in the scatter of measurements, yet persistent, rises and falls that mirrored each other, as though Atlas were breathing in some hidden rhythm. Dust jets should have been chaotic, driven by uneven heating across the surface, erratic and unpredictable. But the oscillations in Atlas's light did not look like chaos, they looked like pulses. The possibility chilled even the most skeptical minds. A pulse suggests control, or at least coherence. A fragmenting comet does not breathe in patterns. A shattered shard does not flicker with intervals that repeat across nights of observation, and yet the data hinted otherwise. Some astronomers argued for natural causes, resonance between its rotation and sublimation jets, producing regular bursts as the same fractured regions faced the sun again and again. Others spoke of tumbling harmonics, a multi-axis spin that produced repeating signatures in the way light reflected off irregular surfaces. But even these explanations strained, their complexity a sign of theories stretched to fit an unease that refused to leave. For what the patterns most resembled were signals, not deliberate transmissions in radio frequencies, as some had half-jokingly hoped for with pulsars in the 1,960 seconds, but signatures all the same, light waxing and waning in a rhythm that could be read, if only we knew the language. The thought lingered uncomfortably. If Atlas were not natural, if it were instead a fragment of technology, then its light might be more than reflection. It might be communication, a beacon flickering across the void, too faint for our crude instruments to pass fully. The missing data, the redacted silences, only deepened the suspicion. What if those absent frames contained the clearest pulses of all? Patterns do not lie. They whisper of underlying truths, whether carved by physics or by intention. In Atlas, the patterns that emerged blurred that boundary. Were we seeing the mechanical repetition of fractured rock or the deliberate cadence of something built? The answer never came. The comet continued its passage, pulsing faintly in its light, drifting further from our reach with every day. Yet, in those repetitions, those half-hidden signatures, humanity glimpsed the possibility that the cosmos was not only vast and indifferent, but patterned in ways we had not yet dared to imagine. And if the patterns were not random, then the question that follows is inevitable. Who or what had written them? Science is not only the pursuit of truth, it is the negotiation of doubt. When 3I Atlas began to unravel the certainties of cometary behavior, the scientific community found itself split. For some, the anomalies were the product of noise, of incomplete data, of the unavoidable gaps that come with studying a faint, distant body at the edge of instrumental sensitivity. For others, the anomalies demanded acknowledgement, a confrontation with the possibility that Atlas was not what it seemed. In conference halls and journal submissions, the division became clear. On one side stood the guardians of caution, those who argued that brightness, fluctuations, odd trajectories, and spectral inconsistencies could all be explained by the known chaos of comets. They cited fragmentation, jets of sublimating gas, multi-axis tumbling. Do not, they warned, mistake complexity for strangeness. For them, to leap toward exotic explanations was to betray the discipline of science, to confuse speculation with observation. On the other side, however, voices began to rise, not reckless, not sensational, but insistent. These astronomers noted how each conventional explanation required stretching the data, bending models until they nearly broke. Why did Atlas repeat the same patterns across nights? Why did its trajectory demand a radiation pressure effect stronger than theory allowed? Why did its chemistry contradict itself? Piece by piece, the anomalies refused to be drowned in cometary excuses. The debate spilled beyond academia. Journalists seized on the fractures, amplifying speculation. Some headlines leaned into the possibility of alien technology, echoing the controversies of Oumuamua. Others dismissed it outright, framing believers as desperate for attention. Within the community, reputations became tethered to which side of the divide one occupied. To admit curiosity was to risk ridicule. To cling to orthodoxy was to risk blindness. This division is not new. When Einstein proposed relativity, the physics establishment resisted, clinging to Newton's order. When pulsars first announced themselves with their perfect rhythm, even Jocelyn Bell herself wondered if she had stumbled upon signals from extraterrestrial intelligence. Science advances not through consensus, but through tension, the friction of minds unwilling to surrender their certainty. Atlas became another battlefield of this eternal struggle. Was it merely a comet, fragile and fractured, misunderstood by the limits of our tools? Or was it something that pressed against the boundaries of known physics, hinting at a category of object we had not yet imagined? The community split, not just in explanation but in philosophy. And beneath the arguments lay a deeper truth. The universe does not bend to consensus. Whether natural or not, Atlas moved on, indifferent to human quarrels. Its mystery was not lessened by division. If anything, the fractures in the scientific community mirrored the fractures in the comet itself, a body split, unstable, yet still bound by forces unseen, drifting forward into the abyss. There comes a moment in every great scientific mystery when whispers grow bolder, when speculation leaves the realm of private conversation, and begins to seep into public imagination. With 3I Atlas, that moment arrived when the data refused to yield to ordinary explanations. Its light flickered with rhythm, its trajectory bent under exaggerated radiation pressure, its chemistry contradicted itself, and its shape resisted clarity. Against this backdrop, a theory long considered taboo began to surface once again. What if this was not natural at all? The idea of alien design did not emerge in a vacuum. Oumuamua had primed the world for it. When Avi Loeb, a Harvard astronomer, suggested that Oumuamua might be a fragment of extraterrestrial technology, a derelict probe or a light sail, the scientific establishment bristled. Many dismissed it as reckless. Yet the idea spread, igniting cultural fascination, for it gave a name to the unease that data alone could not silence. And now, as Atlas unfolded its contradictions, the same unease deepened. If Atlas were artificial, what might it be? Some speculated it was a relic, a broken shard of a greater structure, perhaps a fragment of a vast sail designed to drift between stars, a technology to harness starlight as propulsion. Others wondered if it was a probe not active, not transmitting, but dormant, an ancient messenger from a civilization long vanished. More radical voices even suggested intentionality in its flickers, the possibility that the light curves themselves might encode a message. But even among those open to the possibility, caution reigned. To declare alien origin is to court ridicule, to invite skepticism that can end careers. Most scientists framed such speculations as thought experiments, not conclusions. If, they would say carefully, this were artificial, it might behave like this. And inevitably, the parallels with Atlas's behavior became difficult to ignore. The theories ranged wide. A derelict solar sail, tattered but intact enough to catch the sun's light. A hollow probe, its mass too low for its size, drifting without power. A fragment of interstellar debris, not natural but manufactured, the broken limb of a machine lost to time. Each idea was both thrilling and terrifying, for it suggested that the galaxy is littered not only with rocks and ice, but with relics of intelligence. Still, the counterpoint remained strong. Nature is cleverer than imagination, skeptics reminded. Jets of sublimating ice can mimic strange accelerations. Fragmentation can mimic pulses. Unusual chemistry can arise in alien systems without requiring technology. But beneath these reassurances, a deeper unease lingered. For if 3I Atlas was simply a comet, then it was a comet that mocked our ability to categorize it, a body whose every property seemed to whisper of design. And so the whispers grew louder. Theories of alien design remained speculative, fragile, and often ridiculed, yet they persisted because the anomalies persisted. The comet itself would not settle into the role of ordinary. It resisted every box, every label, until only the most extraordinary possibilities remained on the table, possibilities that forced humanity to confront not only the limits of its science, but the fragility of its certainty. Amidst the growing tide of speculation, there were voices of restraint, voices that rose not in ridicule, but in the measured cadence of caution. They reminded the world that comets are messy, chaotic things. They fracture, they outgas, they spin in irregular ways that defy easy models. They are relics of planetary formation, yes, but they are also fragile icebergs adrift in sunlight, vulnerable to every thermal crack and every collision along their path. To expect them to behave tidily is to misunderstand their nature. For these skeptics, 3I Atlas was not extraordinary in design, but in circumstance. It was interstellar, yes, a fragment born in another star system, and that alone made it rare. But rare did not mean alien. They pointed to natural mechanisms with a persistence equal to those who speculated otherwise. The flickering light? That could be jets of sublimating gas, unevenly distributed, turning on and off as the comet rotated. The erratic trajectory? That too could be explained by outgassing, subtle but cumulative thrusts that shifted its path. The chemical inconsistencies? Surface heterogeneity, a patchwork of ices exposed at different times, each revealing different signatures as the comet spun. To these scientists, the narrative of alien craft was a dangerous distraction. It risked turning rigorous astronomy into spectacle, obscuring the natural marvel with sensationalism. They recalled Oumuamua, how debates over solar sails and alien probes had overshadowed the equally astonishing fact that it was the first interstellar object ever observed. To them, Atlas was extraordinary enough as it was. To demand more was to diminish the true wonder of discovery. And there was precedent for caution. Comets within our own solar system have surprised us with sudden outbursts, fragmentation events, and unpredictable brightening. Hale-Bopp split unexpectedly. Shoemaker-Levy 9 broke into fragments before colliding with Jupiter. These events, dramatic and irregular, showed that cometary behavior can mimic patterns that seem unnatural but are rooted in fragile physics. Why, then, should Atlas be any different? Yet even the skeptics admitted unease. The scale of the anomalies pressed heavily, requiring explanations layered upon explanations. Each inconsistency could be explained, yes, but the accumulation strained credulity. Was it coincidence that so many oddities aligned in a single body? Or were scientists stretching known physics to cover cracks that demanded a new understanding? The voice of caution was not wrong, it was necessary. It reminded humanity that wonder does not require extraterrestrial intent to be profound, that even a fragile, crumbling comet can speak volumes about the birthplaces of stars, the chaos of planetary systems, the fragility of worlds beyond our own. And yet, by standing firm against speculation, the skeptics inadvertently sharpened the divide. For every cautious voice, there was another ready to whisper, "But what if?" And so Atlas remained suspended between explanations. Was it merely a comet unraveling in sunlight, or something more? The voices of caution held the line, but they could not silence the riddle itself. For every natural model proposed, the comet seemed to slip free, its strangeness refusing to be contained. Beneath the more grounded debates of ice, dust, and jets, there emerged whispers of a theory, more terrifying, a theory that shifted the discussion from comets to the very fabric of existence. It was called vacuum decay, and though few dared connect it directly to 3I Atlas, the timing of its anomalies stirred imagination toward the unthinkable. Vacuum decay is not about rocks or sails, but about reality itself. Quantum field theory teaches that our universe rests in what physicists call a false vacuum, a precarious plateau of stability, not the lowest energy state possible. If ever a bubble of true vacuum were to form, it would expand at the speed of light, rewriting physics in its path, annihilating everything we know without warning. This is not science fiction, it is a consequence of equations. The universe, in this view, lives on borrowed time. And so, the darker minds wondered, could the strange behavior of 3I Atlas be a symptom, not of cometary oddities, but of interactions with fields deeper than matter itself? Its inconsistent chemistry, its unexplained acceleration, its patterned flickers. What if these were not anomalies of rock and ice, but scars of a deeper instability? A traveler, they proposed, might carry within it evidence of regions where physics itself differs. Perhaps Atlas was born in a system where vacuum decay had already begun, flung across space as the last relic of a doomed reality. It was speculation at the farthest edge of science, yet it struck a chord. For physicists already know that interstellar objects are messengers from environments we cannot reach. They carry chemical fingerprints of alien stars, structural evidence of collisions in unknown systems. If they can carry those stories, why not deeper ones, stories etched not in rock, but in the quantum fabric of space itself? The fear was not that Atlas was causing such instability, but that it was revealing it. That its strange responses to sunlight, its refusal to conform, were whispers of a deeper truth. That the universe's foundation is less stable, less permanent than we wish to believe. Most astronomers dismissed such speculation as poetic rather than practical. Vacuum decay, after all, is not detectable in the light of a comet. Yet the association lingered, a shadow beneath the debates. For if even the faintest chance existed that 3I Atlas carried with it evidence of deeper physics, physics tied to the end of reality itself, then the object was not just a curiosity, it was an omen. In the quiet corners of forums and late-night discussions, the thought repeated, what if the comet's strangeness is not about itself, but about us? What if Atlas is a mirror, revealing that our universe is fragile, its laws temporary, its stability borrowed from chance? And what if, as it drifted past, it left us with nothing but the awareness that the ground beneath existence is thinner than we dared to believe? When ordinary explanations fail, imagination turns toward what lies beyond our reach. For 3I Atlas, the failure of cometary models, the unease of radiation pressure, and the defiance of gravity all gave rise to a tantalizing possibility that it might not be a natural body at all, but a fragment of technology. And at the heart of this speculation stood one idea above all others, the notion of a quantum sail. The concept is not foreign to science. Humanity itself has dreamed of sails that ride starlight. Thin sheets, vast but weightless, pushed by photons across the gulf between stars. The Japanese spacecraft IKAROS tested such technology, unfurling a solar sail in 2010. NASA's LightSail projects have carried the dream further. The Breakthrough Starshot initiative imagines fleets of sails, each no larger than a postage stamp, propelled to near light speeds by lasers. These are not fantasies. They are prototypes of a future where light itself becomes propulsion. And so, when Atlas seemed too light for its size, too easily nudged by radiation, the parallel was irresistible. What if it was a sail, not of human making, but of another civilization? Not a working probe, perhaps its silence in radio and its erratic motion suggested dereliction, but a relic, a broken wing of technology, drifting across eons, caught by our sun for only a moment before vanishing again into the abyss. Theories of quantum sails reached further still. Unlike ordinary solar sails, a quantum sail might be engineered to interact with not only light, but the quantum vacuum itself. Harnessing fluctuations of empty space, it could drift without fuel, powered by the ceaseless hum of the universe. Such concepts live at the edge of physics, yet they are whispered in speculative papers, dreamed of in thought experiments. And Atlas, fragile and anomalous, fit too neatly into the outline of such a dream. Skeptics pointed out that nature can mimic sails. A fractured comet, porous as foam, could behave as though its surface-to-mass ratio were enormous, catching sunlight like a thin sheet. Dust could shroud it, scattering photons in deceptive ways. Yet even these natural explanations fed the analogy rather than banishing it. For whether natural or artificial, Atlas moved as though it were lighter than it should be, a ghost adrift on starlight. The speculation was not that Atlas was an active craft, but that it was a relic. Perhaps it had once been part of something larger, a probe, a vessel, a beacon. Perhaps it was a grave marker of a civilization long extinct, drifting as cosmic flotsam. Or perhaps it was nothing more than a shard of alien engineering, broken in its own star system and cast outward forever. Quantum sails, in their elegance, capture human imagination because they marry fragility with endurance. A sail is delicate, easily torn yet in the void, with no atmosphere, no storms, it can endure for millennia, drifting where gravity and light command. Atlas seemed to embody that paradox. Too fragile to be natural, too persistent to be dismissed. And so, in its frailty, 3I Atlas hinted at a possibility larger than itself, that the galaxy may not only be filled with planets and stars, but also with relics of technology, sails unfurled to no destination, their journeys eternal, their silence absolute. Tracing the origin of an interstellar visitor is like following the echo of a whisper in a cathedral of stars. The moment 3I Atlas was identified as hyperbolic inbound from beyond the sun's gravity, well, astronomers turned their attention backwards. Where did it come from? Which star flung it into the abyss? What past did it carry in its silence? The method is simple in principle, though fraught with uncertainty. Its trajectory today is measured precisely, its speed and angle relative to the sun known. Rewind the equations, account for the motions of nearby stars, and one can trace the comet's journey through the galaxy. With luck, the path may intersect a star system, pointing to a birthplace. But with Atlas, luck faltered. Its velocity was immense, and even small uncertainties compounded across millions of years. Some models traced it back toward the constellation of Cassiopeia, others pointed nearer to Perseus. One solution hinted at origins in the direction of a star-forming region, where dense molecular clouds collapse into suns. Another whispered of a dying star system, one shedding its fragments as planets tore each other apart. None agreed. Yet in the chaos, a theme emerged. Atlas did not come from nowhere. Its motion was not random. It bore the signature of ejection, a body hurled outward from the violent birth or death of worlds. Perhaps it was cast free during the early youth of a system, when giant planets scatter comets like seeds. Or perhaps it was the debris of catastrophe, a collision, a star's tidal forces ripping a planet to fragments, each shard flung outward to wander forever. The chemistry of Atlas, rich in exotic volatiles, suggested extreme cold. That pointed toward formation at the edges of its native system, far from its parent star, where ices could remain unlit and untouched. Yet the inconsistency of its spectrum hinted at complexity, perhaps a system unlike ours, one where conditions defied familiar categories. The thought was staggering. Here was matter that had once orbited another sun, perhaps billions of years ago. It had seen skies we will never see, felt the gravity of worlds unknown, existed under constellations alien to our own. And now, after drifting across the void for epochs, it brushed against our solar system like a ghost passing through a doorway. Speculation deepened further. What if its trajectory had not been entirely natural? What if, like a sail, it had been nudged deliberately, not aimed at Earth perhaps, but launched outward by design? To trace its birthplace, then, was not merely to reconstruct a past, but to ask whether that past belonged to nature alone. The backward maps ended in uncertainty, but they framed a haunting truth. Atlas carried within it the memory of another star system's story. Whether ejected by chance or by craft, it had traveled for uncountable millennia before intersecting our lives. To trace its origin was to glimpse, faintly, the broader reality that we are not alone in our histories, that the galaxy is filled with worlds whose fragments may someday drift into ours. And Atlas, broken and strange, was one such fragment, a messenger from a birthplace we may never pinpoint, but one that whispered of violence, of distance, and of the eternity of wandering between stars. Every interstellar object is more than a stone or a shard. It is a chronicle written not in words but in scars, carrying within it the history of its journey. With 3I Atlas, astronomers tried to read that chronicle, to imagine the vast and silent odyssey that had brought it from some distant star into the arms of our Sunday. What emerged was a portrait not of years, but of millions upon millions of years adrift through the dark that dwarfs human time. Its velocity suggested an exile long untethered. At tens of kilometers per second, Atlas must have been set free eons ago, perhaps when its home system was still young, flung outward by the gravity of giant planets or the collapse of stellar companions. Once beyond its sun's reach, it entered the greater ocean of the galaxy, joining the endless stream of debris that drifts unseen between stars. This is not emptiness but a river, a slow tide of bodies, comets, asteroids, fragments of shattered worlds migrating across the Milky Way in silence. Astronomers reconstructed its path, not a straight line, but a meandering thread tugged by the gravity of passing stars, bent by the invisible arm of the galaxy itself. Each close encounter would have shifted it slightly, altering its course, a billiard ball struck by unseen hands. Over millions of years, these nudges accumulated, erasing memory of its origin, shaping instead the randomness of its arrival here. The chemistry of Atlas hinted at how it endured that eternity. Rich in volatile ices, it must have remained frozen in the deep cold, far from any warmth that could awaken it. For most of its journey it was invisible, a ghost in interstellar dark, drifting through regions where stars were sparse, where even cosmic rays seemed too faint to stir it. Only when chance directed it toward our sun did it flare into visibility, breaking its silence with a brief moment of light. But if its path was long, it was not purposeless. Interstellar objects like Atlas are thought to be common countless fragments cast adrift, their journeys spanning galactic lifetimes. Each is a messenger, carrying the physical memory of systems that lived and died before us. In their trajectories, we glimpse the restless nature of creation itself. Stars form, planets collide, systems evolve, and fragments are sent outward, carrying with them the echoes of their birthplaces. And yet, with Atlas, the echoes seemed louder, stranger. Its anomalies made some wonder if its path was not wholly random. Could a sail, natural or artificial, have altered its course? Could encounters with exotic environments, black holes or stellar remnants, have imprinted its strangeness? Its million-year drift was not only a story of distance, but of transformation, of unknown encounters that may have reshaped its essence. To speak of Atlas's journey is to confront scale. While humanity measures its history in millennia, Atlas may have been traveling for 1 billion years, longer than life has existed in its current form on Earth. It is not just a visitor, it is an ancient, a relic older than our species, older than our civilizations, older even than our world's continents as they are arranged today. And so, as it passed through our system, fleeting and fragile, we were reminded that the universe is not static, it drifts. It carries its memories across gulfs of time so vast that our lives are but a flicker. 3i Atlas was a drifting page torn from that endless chronicle, a traveler from the dark, bearing silent witness to ages we cannot comprehend. Why now? Why here? The question haunted astronomers and philosophers alike as 3 Atlas traced its arc through the inner solar system. To say that it was coincidence is true in the simplest sense. Interstellar objects drift perpetually, and from time to time, by sheer probability, one will intersect our small corner of the galaxy. Yet coincidence does not quiet the deeper unease. For the cosmos is vast beyond measure, and the fact that in the span of mere years, 3 interstellar visitors have brushed against our star feels less like chance and more like design. Consider the timescale. For billions of years, Earth orbited in silence, untouched by such recognized wanderers. Oumuamua arrived only in 2017, Borisov in 2019, and now Atlas. 3 emissaries in less than a human decade, after eons of invisibility. The odds press heavily on the imagination. Had our instruments suddenly become sharp enough to notice what was always there? Or had something shifted, some hidden tide in the galaxy sending fragments our way? The unease is sharpened by the timing. Humanity, for the first time in its history, has developed the tools to perceive such wanderers. Pan-stars, Atlas, ESA's telescopes, all scanning the skies with precision unthinkable a century ago. Perhaps the visitors were always here, unnoticed, and yet the timing invites reflection. Just as our species awakens to interstellar scale, the universe seems to answer, placing in our skies objects that whisper of other suns, other histories. The philosophical tension grows deeper still. If Atlas were merely one fragment among countless millions, what does that say of our place in the galaxy? That our solar system is not isolated, but porous, constantly intersecting with the debris of alien worlds. Each visitor is a reminder that we are part of a wider ecology, a cosmic interchange where matter wanders freely, carrying the stories of stars across impossible gulfs. But if, even faintly, the anomalies point to design, the question becomes more profound. Why here, and why now? Could such objects be dispatched deliberately, sent across millennia to drift into the paths of civilizations just waking to the stars? If so, then our encounter with Atlas is not coincidence, but contact, though a contact subtle, ambiguous, easily dismissed. And yet, perhaps the real lesson lies in the humility of chance. Whether natural or not, the timing forces us to reflect on our readiness. Are we prepared to interpret the messengers the galaxy sends us? Or do we still lack the language, mistaking design for chaos or chaos for design? Atlas did not answer these questions, it only provoked them. Why now? Why here? The universe offered no reply, only silence, and in that silence, the unsettling thought that the arrival of such objects is not just an astronomical event, but a mirror held to our own uncertainty about meaning itself. As 3I Atlas drifted deeper into the inner system, the scientific community scrambled to sharpen its gaze. For every anomaly, every unanswered question, there remained one solution: better data. Theories could multiply endlessly, but only instruments the silent eyes of humanity cast into space could hope to reveal the truth. And so, telescopes turned. Ground-based observatories across the globe, from Hawaii to Chile to the Canary Islands, adjusted their schedules, squeezing Atlas into already crowded nights of observation. Robotic surveys like Pan-STARRS and Atlas itself tracked its fading glow, while ESA coordinated with partners to capture high-resolution imaging whenever possible. Space telescopes, freed from atmospheric blur, joined the chase, their instruments tuned not only to visible light, but to infrared, ultraviolet, and beyond. Each wavelength promised a different story. Infrared could reveal heat, whispering of sublimation hidden from the eye. Ultraviolet could trace exotic gases, their signatures faint against the black. Polarimetry, the study of light's polarization, could hint at the structure of its dust, whether it was ordinary grains or something stranger. In this symphony of instruments, humanity strained to translate the comet's silence into meaning. But observation was not only about the present. Astronomers combed through archival data, hunting for Atlas before its official discovery, faint traces buried in survey images. Every extra point of light, however dim, could refine its trajectory, tighten the models of its origin, and sharpen predictions of its path. Some even reached further, examining whether earlier anomalies unexplained, streaks in old sky maps, might have been unnoticed, interstellar wanderers like this one. Technology itself became part of the narrative. The rise of automated surveys, the spread of high-sensitivity detectors, the coordination of networks across continents, all had made it possible to catch Atlas at all. Just decades ago, such an object would have passed unseen, a ghost unmarked in our skies. Now, our instruments stitched together its story in real time, revealing enough to disturb, but never enough to settle the mystery. And yet, no matter how sharp the data, the comet resisted. Spectrographs contradicted one another. Light curves flickered inconsistently. Trajectory models bent beneath uncertainty. It was as though the more closely humanity looked, the more the object retreated, cloaking itself in ambiguity. Still, the chase continued. For scientists, to turn away was unthinkable. To glimpse a messenger from another star and not pursue it with every tool at hand would be to betray curiosity itself. And so the telescopes tracked, the detectors hummed, the data streams filled with numbers that did not agree. Atlas moved on, slipping further each night, but the instruments remained fixed, determined to wring from it one last confession. In that relentless pursuit lay both triumph and tragedy. Triumph that humanity could marshal such power to chase a faint smear of light across billions of kilometers. Tragedy that even this power yielded only riddles. For science could sharpen its gaze, but Atlas seemed to sharpen its silence in reply. The mystery of 3I Atlas was not confined to the present. As its faint light crossed observatories night by night, astronomers turned backward in time, combing through the archives of the sky. For decades, robotic surveys had swept the heavens, recording every glimmer, every streak. Somewhere in those vast digital vaults might lie whispers of Atlas before it was known, faint traces overlooked, catalogued as noise, forgotten until its importance became clear. This process is called archival mining. It is a form of cosmic archaeology, sifting through the past with algorithms that hunt for consistency in chaos. And in those records, scattered across observatories worldwide, fragments began to emerge, a dim streak in a survey image from weeks before its official discovery. A pixelated anomaly in an all-sky frame nearly lost to background stars. Each recovery stretched its observational arc, refining its trajectory, chiseling away at the uncertainties of its path. But more intriguing still was the re-examination of anomalies once dismissed. Astronomers began to ask, had Atlas been seen even earlier, months or years before, mistaken for a different comet or an asteroid? Were there other interstellar wanderers hidden in the noise of history, misclassified because no one thought to look for hyperbolic trajectories? With the lessons of Oumuamua and Borisov in hand, the archives were now haunted with possibility. The search did not stop at images. Radio data, photometric logs, even spacecraft readings of dust and particles were reanalyzed, seeking correlations. Some researchers claimed to find faint signals of outgassing inconsistent with known comets. Others reported statistical rhythms buried in photometric noise, not definitive, but suggestive, like a heartbeat hidden beneath static. And then there were the stranger claims. Amateur astronomers, long keepers of their own archives, resurfaced old photographs and logs, some dating years back. A few swore they had caught unexplained streaks that might align with Atlas's retro-calculated path. None were conclusive, but together they painted a picture of an object that had brushed our awareness before discovery, hiding in plain sight. This raised a profound possibility that Atlas was not alone. If archives contained overlooked interstellar visitors, then perhaps the galaxy sends far more of them through our system than we had believed. Perhaps Earth has always been visited, again and again, by wanderers from other suns, and only now, with the precision of modern tools, do we begin to notice. But in the noise of data, meaning is slippery. Patterns may emerge, but whether they are real or illusions of coincidence remains uncertain. Some scientists cautioned that archival claims were often wishful human minds, weaving stories from scattered pixels. Yet even in skepticism, the act of searching mattered. It meant humanity was no longer content to wait passively for interstellar messengers. We had begun to listen to the whispers hidden in the static, to mine the silence for signs we had once ignored. In that researching of the past, Atlas deepened its enigma. It was not only a mystery of the present moment, but a ghost haunting the archives, reshaping how we see all the sky's forgotten records. The object itself was fleeting, but its shadow fell backward, compelling us to wonder how many messages from the stars we have already overlooked. As weeks turned to months, the European Space Agency continued to release new images of 3I Atlas. Each update was greeted with anticipation, as though the next exposure might finally unravel the contradictions. Yet instead of clarity, the images deepened the riddle. They were sharper, yes, taken with instruments of extraordinary precision, yet even in sharpness, the comet refused to conform. Some frames showed it brighter than models predicted, its coma swelling asymmetrically as though light were leaking from one side. Others showed it fractured, its glow split into uneven lobes like shards, refusing to orbit a common center. And, in the long exposures, a faint smearing persisted, as if the comet's path itself were unstable, shifting between measurements. Officially, ESA attributed much of this to fragmentation. The comet, they suggested, was breaking apart under the stress of solar heating, shedding fragments too faint to be resolved individually. This was consistent with known cometary behavior. Fragile bodies do often shatter when drawn too near the sunday. Yet the explanation failed to satisfy. The images hinted at something more structured, less chaotic, as though the pieces were not random rubble but parts of a whole reluctant to disintegrate. The updates came with carefully worded statements, technical, reserved, designed to inform without inflaming speculation. Yet the public, and even many scientists, noticed the hesitations between the lines. Why did some images arrive weeks late? Why were brightness curves cropped short or trajectories updated only after unexplained revisions? The impression grew that the agency was cautious, perhaps overly so, aware that Atlas had become more than a comet in the eyes of the world. For the images themselves fed that perception. In one set, faint linear streaks appeared in the halo, too regular to dismiss easily. In another, the coma brightened and dimmed between exposures taken only minutes apart, as though pulsing. Astronomers debated whether these were artifacts of instruments or genuine properties of the object. But in the court of imagination, the verdict was already reached. Atlas was hiding something. The agency's silence only amplified the unease. Each official release was both revelation and riddle, each photograph another mirror of uncertainty. The comet itself seemed to play a cruel game, offering just enough detail to sharpen questions while withholding the answers. And so, with each ESA update, humanity's fascination deepened. The object was not fading from memory as most comets do. Instead, it became an icon of ambiguity, a symbol of the limits of observation, of the silence that lingers even in the face of our best instruments. In the end, the updates did not resolve the mystery. They sharpened it. The more clearly we saw Atlas, the less we seemed to understand. It was a paradox caught in pixels, a wanderer that grew stranger the closer it came into focus. And with each new release, humanity was reminded that sometimes knowledge does not banish mystery. Sometimes it multiplies it. As the comet's reputation spread beyond observatories, its enigma leapt into the broader imagination. 3I Atlas, though faint and distant, became more than an object of scientific scrutiny. It became a canvas onto which humanity projected its oldest hopes and fears. News outlets, hungry for wonder, framed it as the new Oumuamua, stoking memories of the unresolved debates that still haunted the astronomical community. Headlines danced between caution and spectacle. Some emphasized the comet's alien chemistry, others whispered about its sail, like motion, still others speculated about its connection to life itself. Each article added fuel to a cultural fire already kindled by curiosity. In online forums and social media, speculation bloomed unchecked. Was Atlas a fragment of an alien probe? Was it a derelict beacon, pulsing faintly as it drifted past? Was it, perhaps even sent intentionally, a slow messenger aimed not at us specifically, but at any civilization capable of noticing? For every sober voice insisting it was a fragile comet, there were a dozen others spinning tales of ancient technologies, cosmic warnings, or silent greetings carried across eons. Artists began to render it not as a faint smudge, but as a gleaming shard of silver, a sail torn by ages of drift, a broken vessel adrift in eternal night. Poets and philosophers seized on its symbolism, describing it as a mirror of humanity itself, fragile, uncertain, wandering through a cosmos that offers no map. Even speculative fiction absorbed it, weaving Atlas into stories of interstellar contact, of civilizations revealed not through signals, but through wreckage. For culture, Atlas mattered not because it was understood, but because it resisted understanding. Mystery has always been fertile ground for imagination, and this comet embodied mystery perfectly too strange to be ordinary, too silent to be explained, too fleeting to be grasped. Within the scientific community, this surge of fascination was met with mixed feelings. Some welcomed it, believing that wonder even dressed in speculation was a spark for public interest in science. Others feared it distorted reality, turning sober astronomy into spectacle, distracting from the real marvel that interstellar objects exist at all and that we can now glimpse them. But whether welcomed or resisted, the cultural storm could not be denied. For in truth, humanity has always read the sky not only with science, but with myth. Comets were once omens, portents of doom or change. Now, in the age of telescopes and data, they remain symbols no longer divine warnings, but cosmic riddles that remind us of our smallness. Atlas joined this lineage, not as a harbinger of kings' fates, but as a harbinger of questions about life, about technology, about what else drifts unseen in the dark between stars. The human imagination ignited because Atlas offered no closure. It was not an answered question, but an open door. And through that door, culture, art, and philosophy rushed, eager to turn a faint smear of light into a story about ourselves. There came a point in the unfolding story of 3I Atlas when scientists were forced to admit the limits of their tools and even the limits of their frameworks. For centuries, astronomy had relied on Newton, refined by Einstein, and more recently intertwined with the strange domains of quantum physics. These laws had sufficed for planets, for stars, for galaxies. But for Atlas, the rules seemed to strain. Its deviations could be modeled. Yes, radiation pressure added to gravitational pull, sublimation jets added to mass estimates, fragmentations folded into brightness curves. Yet the more corrections were applied, the less satisfying the models became. The comet seemed to slip through the cracks of explanation, requiring one exception after another until the elegance of physics turned into patchwork. And physics resists patchwork. It craves unity. Einstein's relativity describes the dance of gravity, bending space-time with precision that has held against a century of scrutiny. Quantum field theory describes the invisible particles and forces that shimmer beneath matter, tested with particle accelerators and detectors across the globe. Yet between these two great frameworks, a gap remains: the unbridgeable rift between the cosmic and the quantum. And in anomalies like Atlas, some wondered if we were brushing against that rift. Could the comet's strange light curve be an echo of quantum coherence, its particles interacting with radiation in ways our models oversimplified? Could its exaggerated response to sunlight hint at subtleties of vacuum energy, the mysterious dark fabric that makes up most of the cosmos? Or was it simply that our instruments, precise though they are, still falter when confronted with objects too faint, too brief, too distant? In conference papers, cautious phrases appeared. Non-gravitational acceleration inconsistent with standard models, rotational dynamics not fully constrained, spectral variability unexplained. Each was a technical way of admitting ignorance, a reminder that science, for all its authority, is still a map drawn in pencil, not ink. And in this humility lies the real significance of Atlas. It is not simply a comet that may or may not behave strangely. It is a messenger reminding us that the universe is larger than our equations. It exposes the edge of the map, the boundary where certainty dissolves into mystery. For some, this is unsettling. For others, it is exhilarating. It means there is more to learn, more to imagine, more to seek. Hawking once said that the greatest enemy of knowledge is not ignorance, but the illusion of knowledge. In Atlas, that illusion cracked. The comet forced physicists to confront the possibility that their frameworks, though vast, are incomplete. And perhaps that is its true gift. Not an answer, but a question sharpened so acutely that we cannot ignore it. To stand at the edge of current science is to stand in awe. We are reminded that every discovery is provisional, every explanation temporary. Atlas, fragile and fleeting, passed through our system as a reminder that the cosmos is not finished with us, that it still holds secrets capable of humbling even our most confident laws. For all the unease, for all the contradictions, one truth remained undeniable. Atlas changed us. It reshaped how astronomers think about comets, how physicists grapple with anomalies, and how humanity envisions its place in the galaxy. It was not just a curiosity to be catalogued. It was a teacher, even in its silence. Atlas taught us that interstellar comets are not rare accidents. The rapid arrival of 3 such objects within a handful of years, Oumuamua, Borisov, and now Atlas, suggests they may be far more common than once believed. The galaxy may be filled with them, drifting between stars like seeds scattered on cosmic winds. If so, each one is a messenger, carrying the chemistry and physics of alien systems into ours. To glimpse them is to glimpse the diversity of worlds we will never touch. It taught us humility in the face of data that does not conform. In science, anomalies are often dismissed as noise, errors, artifacts of instrumentation, yet Atlas reminded us that anomalies are also opportunities. Its brightness betrayed expectations, its trajectory defied prediction, its chemistry contradicted itself, and in each contradiction lay the possibility of new knowledge, new physics waiting to be uncovered. It taught us to listen differently. No longer can astronomers ignore the faint flickers in survey archives, the unremarkable streaks dismissed as noise. Atlas forced the community to re-examine decades of forgotten data, to recognize that we may already have glimpsed many interstellar travelers without realizing it. Our sky is not a closed stage, but a crossroads where wanderers pass in silence. Most of all, it reshaped the imagination. For scientists, it challenged models of cometary dynamics, radiation pressure, and interstellar chemistry. For philosophers, it raised questions about coincidence and purpose, chance and design. For culture, it ignited speculation about technology adrift in the void, about sails and probes, about civilizations lost or waiting. In its ambiguity, it became more powerful than certainty. To say that Atlas teaches us is to admit that teaching does not always arrive in answers. Sometimes it arrives in questions, in riddles that resist resolution. It teaches by unsettling, by showing us that the universe is stranger than the categories we use to contain it. And so, when the comet faded from view, slipping once more into the silence of the outer dark, it did not leave us empty-handed. It left us with sharper eyes, wider imaginations, and deeper humility. It forced us to reconsider what interstellar comets are, what they can reveal, and what they may yet conceal. Atlas became, in the end, more than a fleeting smear of light. It became a lesson that the cosmos is restless, that its messengers are many, and that each one reshapes the story of how we see the universe and how we see ourselves. And yet, for all the telescopes turned toward it, for all the equations scribbled across blackboards and the papers debated in hushed conference halls, 3I Atlas left us with more shadows than light. It slipped into our system like a question mark, lingered just long enough to ignite 1,000 hypotheses, and then retreated back into the abyss without surrendering its truth. The silence it left behind was louder than any data. Even at its brightest, Atlas never spoke plainly. Its trajectory refused to obey prediction, its brightness betrayed expectation, its chemistry contradicted itself. Its shape slipped between models like a phantom, and when the final images were taken, when its faint glow dwindled at the edge of detectability, no consensus had been reached. It remained what it was at the beginning, a mystery, unresolved, perhaps unresolvable. There was frustration in this. Science thrives on answers, on resolution, on reducing complexity into understanding. To chase a visitor across the sky only to be left with riddles seemed cruel, like following a trail that ends abruptly at the edge of a cliff. And yet, in that cruelty, there was also beauty. For mystery is not the failure of science. Mystery is the promise of it. It is the reminder that knowledge is not complete, that the universe still holds secrets vast enough to humble us. The unanswered questions pressed heavily. Was Atlas truly a fragile comet unraveling in sunlight, or was it something more deliberate, a relic of technology adrift between the stars? Was its flickering brightness the breath of sublimating ice, or the faint pulse of structure? Was its strange trajectory the product of jets, or the signature of a sail? The silence offered no reply. Even deeper questions lingered. Why do such objects arrive now, in this narrow window of human history, when we finally have the tools to see them? Are we simply more attentive, or is the galaxy more restless than we knew? How many have passed unseen in the millennia before? How many will pass again after we are gone? The mystery of 3I Atlas was not diminished by its silence. It was amplified. Every anomaly became not an error to be dismissed, but a reminder of how little we know. It is easy to believe the universe is mapped, its laws defined, its mysteries confined to black holes and the Big Bang. But then a faint smear of light appears in the night sky, and suddenly the ground shifts beneath us. Atlas left us with silence. Yes, but a silence alive with possibility. In that silence, humanity was confronted not with answers, but with its own reflection. Curious, uncertain, fragile, reaching into the dark and finding only questions. In the end, the tale of 3I Atlas is not only about a comet, nor about the anomalies it carried with it. It is about us. It is about a species that looks upward, straining to read the whispers written in the sky, and finds itself mirrored in the mysteries it cannot resolve. Atlas was a fragment from another sun, yes, but it was also a fragment of our own story, arriving at the moment when humanity was just beginning to step beyond its cradle, daring to wonder whether we are alone. For what Atlas offered was not certainty, but reflection. Its strangeness became a lens through which we saw our own limits. the cracks in our theories, the frailty of our instruments, the smallness of our understanding. It reminded us that even with all our telescopes and equations, the universe can still confound us with a single shard of light. And in that confounding, it awakened awe, the kind of awe that has always been the seed of discovery. Perhaps Atlas was only a comet, fragile and fractured, misunderstood because it was fleeting and faint. Perhaps it was something else. A sail, a probe, a relic drifting across eons, silent but deliberate. We may never know. It is gone now, vanishing into the dark beyond the planets, another ghost in the endless night. But its absence is not emptiness. It leaves behind a question, and sometimes a question is more powerful than an answer. Because in that question lies possibility. The possibility that the galaxy is filled with wanderers, some natural, some perhaps not. The possibility that other civilizations, long vanished or still enduring, have cast fragments into the void that we may one day find. The possibility that our universe is stranger than even our boldest theories allow. And so we are left not with closure, but with wonder. Atlas came, flickered, and was gone. Yet in its brief passage, it reminded us that the cosmos is not silent, not static. It is alive with motion, with riddles, with echoes of stories older than Earth itself. To gaze upon such a visitor is to gaze upon time itself, upon the vastness that dwarfs us and yet somehow includes us. We remain small, uncertain, and searching, and perhaps that is enough. Perhaps the purpose of mysteries like Atlas is not to be solved, but to remind us of what it means to seek to look outward, to question, to be humbled, and to dream. The comet is gone now. The telescopes no longer track its fading light. The instruments no longer hum with its numbers. The charts have been archived, the papers published, the debates left unresolved. What remains is the quiet, and within that quiet, a kind of peace. For the universe is vast, and we are small. That truth can frighten, but it can also comfort. To know that the cosmos holds riddles greater than us is to know that there will always be something beyond the horizon, something worth seeking. Atlas was one such riddle, drifting briefly through our sight, reminding us that mystery endures, that discovery is not a destination but a path. Imagine it now, far beyond the planets, gliding into the cold, a fragment of ice, or a sail, or something we cannot name, slipping once more into interstellar night. It leaves behind no trail, no message, only the faint echo of its passage in our instruments and in our minds, and yet that echo is enough. It whispers that we are part of something immense, something endless, something that will always be more than we can contain. Let the thought settle softly. The stars are not silent. They speak in light, in gravity, in fragments that fall into our system unannounced. And though their language is not one we fully understand, it is one we can learn to listen for. Atlas was a word in that language, fleeting, cryptic, but beautiful. Sleep then, with that comfort. The mystery remains, and so does the wonder. The universe has not finished speaking to us, and as long as we lift our eyes to the dark, it never will. Sweet dreams.